Welcome back to OMG, it's Additional Chemistry. Today we are going to talk about alkanes and alkenes. Okay? So alkanes, they are a homologous series, so everything in there has the same like double bonds, single bonds, things like that, okay? So a homologous series of hydrocarbons, something that contains only a hydrogen and a carbon. The general formula for alkanes, they all share the same general formula, so CnH2n plus 2. Okay, as the chain length increases, their boiling point increases, there's more bonds. So if you counted the number of bonds, there's less bonds in this one by here compared to this one down here. So the more bonds there are, the harder it is to break all the bonds, so their boiling points increase. Alkanes are saturated, which means they've got no double bonds. This means that they're joined by a single covalent bond. Okay, because they're non-metals join into each other, so that's why they're covalent. Relatively unreactive, apart from when they react with oxygen in the air, which is combustion, which makes energy, carbon dioxide and water, which we then use to power things. So next up then, alkenes. Alkenes are a little bit different because they contain a double bond, okay? Their double bond, their general form again is a little bit different, CnH2n. There's no methane because it can't double bond. There's no two carbon double bonds. We say that alkenes are unsaturated, meaning they contain a double bond. They're more reactive, okay, because this double bond is actually quite reactive. Okay, it attracts electrons, so they're much more reactive than alkanes. Right, testing for an alkene or an alkane. Because they look exactly the same if you were to look at them, okay? But alkenes react in a way that alkanes cannot. So if I just had an alkene and an alkane, they'd just be like colourless solutions. What we would then do is add bromine water. Bromine water is orange. It's an orange solution, okay? And what would happen is the alkene will go colourless, the alkane will stay orange. So we add bromine, it's an orange solution. The alkane will stay orange, the alkene will decolorize, okay? The reason it's decolorizing is because it's actually reacting with the bromine, okay? The bromine is actually reacting over the double bond, and we call it an addition reaction because what's happened is the bromine is actually getting added to the compound, and you make something called 1,2,1,2-dibromoethane. So what actually happens is the double bond disappears and you make a new compound. Alkanes can't do this because they don't have the double bond to add across. Isomers, this is a little bit of a tricky topic, okay? So you must remember the definition for an isomer, same molecular formula, different structural formula, okay? Alkenes have two straight chain isomers as the double bond can be placed in different places, okay? So remember to count your carbons, you've got 1, 2, 3, 4. So this would be 1 butene because it's on the first one, and then this one would be 2 butene because it's on the second one, okay? So that's an easy way if you've got a double bond. Okay, another way is to add like a different functional group. So these have got exactly the same number of carbons, exactly the same number of hydrogens, so same molecular formula. But what we've done is we've got one long straight chain of 3 now instead of 4, and we've added a methyl group there. Okay, you cannot add the methyl group on the end, so something like this, 1, 2, 3, and thinking the methyl group on the end. That's not actually an isomer because you could just bend it back up there. Okay, so it has to be on a central carbon for it to be an isomer. Okay, remember the definition, same molecular formula, different structural formula. Naming hydrocarbons, you have to remember to name them. So meth, eth, prop, bute, pent, they're about as high as you get. It might get hex, but you have to be able to name them. If you've got an alkane, it ends in an ane, or alkenes end in ene. Okay, so if I had, let me just draw something out. 1, 2, 3, 4, and I'll draw a double bond. So find the longest branch. This is just one long branch. Okay, number your branches. You got 1, 2, 3, 4. So 4 would be bute. Okay, name any functional groups. So we've got a double bond, so it'd be butene. List L branches in alphabetical order. Alkenes have a double bond which goes in the middle, so this one would be off the bute 3-ene, or if you wanted to do the other way, 1, 2, 3, 4, because you could, it would actually technically be bute 1-ene. Okay, but if we had something more complex, so let's do 1, 2, 3, CH3 and C. So this is when it gets a lot harder and you've got to follow your success criteria. So find the longest branch. My longest branch is here. So that's 1, 2, 1, 2, 3. So it's going to be something to do with prop. Okay, doesn't have a double bond, so I'm going to go with propane because it doesn't have a double bond. Number my branches, we've got 1. I'll go the other way actually. Got 1, 2, 3. You can go either way. I've just decided to go that way because I've got something attached to that. Name all your function groups. So I've got chloro, and I've got a methyl group. So then it would be 1 chloro, because it's on the first one. 1 chloro dash 2 methyl propane. So a little knowledge test at the end then. Have a go, pause the video, and then I'll come up with the answers. So, what is the general formula for alkanes? CnH2n plus 2. It's a general formula for alkenes, CnH2n. How many bonds can carbon make? Carbon can make 4 bonds. Okay, that's really important you remember it. Why are alkenes more reactive? They're double bond. What happens as you increase the chain length, boiling point or melting point? Increases. How do you test for carbon-carbon double bond? Bromine, water. If you've got a carbon-carbon double bond, it'll go from orange to colourless. What's an isomer? Same molecular formula. But a different structural formula. And then draw bute 1-ene. So bute's 4 carbons, ene double bond. So 1, 2, 3, 4. Double bond on the first one because it's 1. So then every carbon's got to have 4 bonds. So it's already got 2 bonds. So it's 1, 2. This carbon's then already got 1, 2, 3 bonds. So it'll have 1 hydrogen coming off. This carbon's got 1, 2. So it'll have 1, 2. And this carbon's got 1, 2. 3. Okay, like I said before, if you got them all right, then you're obviously secure in this topic and you can move on and do another topic. If not, start the video again and have another go.